Hi, I'm John Grundy. I'm from Monash University, and I'll be talking about our work on developing a human-centric approach to building a smarter and better parking application. First of all, I'll talk about the key motivation for our work, talk about our approach, tell you about the personas and user stories we used to support our approach. I'll talk about the prototype app we developed, its evaluation, and some of the key lessons. So smart cities are becoming very popular, and in order to support smart cities, we need to support an extremely wide range of users. By definition, if you like, a smart city needs to support all citizens of different age, gender, culture, language proficiency, personality, emotional reaction to software, socioeconomic status, physical and mental challenges, and so on. And many apps that are currently targeted towards smart city applications fail to do this. Don't do it very well or don't do it very well. So an example is the smart parking app we use at my university. Here's an example of it in use. Has a number of limitations. There's only one way typically of booking a park. It doesn't support users with sight challenges very easily or hearing challenges. It doesn't provide sufficient confirmation for some users. When it's using a number plate recognition system, it sometimes mixes up the 0 and the O and people get parking fines, and doesn't provide a very intuitive interface for many users. To try and improve this, we have set 3 research questions for our study. What are the main human-centric frustrations when we're using these kinds of smart parking applications? How could we develop a much more human-centric smart parking application? And can we make the parking process much more seamless and less stressful for as many users as possible? And what's the influence of a human-centric design of a smart parking app on the experience of a diverse range of end users of the smart parking app? So we started off with developing a range of personas, so personas that represent a range of different people that would typically use a smart parking application. We then use those to build a set of user stories, and then use the user stories to construct the design of a prototype app that would try and satisfy all of the user stories of the personas and address all of the frustrations of the personas with current smart parking solutions. We tested out the prototype with each persona, identified limitations, worked out problems, discussed those, reworked the prototype, continued on doing this until we got as many of the user stories satisfied and as many of the frustrations removed and mitigated. So we developed 5 different personas, again, different ages and genders, some with or without children, some working, not working, some retired. Some were non-English as a first language speakers, some were dyslexic, some were colorblind, some had mobility challenges, and so on. For example here, this fictitious Elizabeth Core persona, a retired woman who's got children and granddaughter, spends a lot of time parking to visit her grandchild, needs to find spots easily. She's got a husband who needs to be taken to the hospital regularly, so needs to park there. She wants to use her phone despite vision issues, so she's got some colour blindness and other issues, and wants to be able to reserve a park rather than kind of go hunting for a park at the destination. We then had some other personas that were quite different to this one. Younger people, different genders, people with different physical and mental challenges, and so on. Then built a range of user stories for each of these personas. Some of the stories were quite similar, one do very similar things, others were very different. And essentially we wanted to make sure that the smart parking app could achieve the same goal for the diverse end users, but possibly by very different means. So a few examples here. We've got a persona of a food deliverer and needs to be able to switch vehicles. So it needs to be very seamless to use a different vehicle and not get a fine, for example. Non-technical background users, which are most people in society, or relatively lower technical proficiency than app developers, want a much easier to use design than many current applications. Then someone's options for parking and be able to book them and reserve them so they can secure them in advance without having to hunt for a park at the last minute. So we developed our personas and used our personas and user stories to develop a set of Figma designs. We tried these out with cognitive walkthroughs of each persona, refined the designs, and tried to make sure all of the user stories and frustrations were met and mitigated. Then brought a prototype. So we had a client and a server and potentiality of having a number of sensors that tell the smart parking app where you parked. These were mocked up for our prototype. We actually wanted to connect the available car parking database to the real-time parking database that we were working on in another project using sensor-based detection. Unfortunately, due to COVID-19 issues, we weren't able to do that, but we built the prototype with that as a functionality in mind. So here's an example of a usage case. So the app allows you to specify a number of characteristics, different languages, font size, font types, etc. You can add vehicles and payment methods. One can search based on a map-based metaphor or list-based metaphor. And then one can select car parks and carry out a booking process. The booking process allowed a number of things to be specified, the length of time and so on. If you were arriving in the future, you could modify the time to say, I want this park reserved for me. As an alternative, you might pay for parking at the time that you arrive, or you might pay for parking in the future. Various supports for diverse end users and challenges. So for example, here on the left, I've got one that shows magnifying different fonts. Now again, this is in-app magnification, not raw platform magnification. So different fonts can be magnified in different amounts, both width and height, and thickness of line. Magnification can be applied to various other parts in different ways as well. It's colorblind mode for different kinds of color blindness, so different kinds of color choices can be made, and then one can switch the app into different languages depending on the preferred language of the app user. And ideally, we would have evaluated the app with a number of citizens that we were working with in our other project. Due to COVID-19 limitations, it was very difficult to set up demonstrations, walkthroughs, feedbacks, and so on. To address this, we use cognitive walkthroughs with apps and personas, and we walk through each user story, having a classmate of the students who built the app, using the characteristics of the persona, testing out the frustrations and goals, and giving feedback on whether the app addressed those sufficiently. We found out most user stories are able to be met versus the example application that we evaluated. And most frustrations also reduced, again, much more so than the example commercial smart parking applications that we tested from there. Some key issues that we found. It's difficult to guarantee a car park registration and reservation without having some kind of sensor and signage on the car park itself. So while this is a very desired characteristic, it's quite hard to implement in practice. Not all first languages are implemented, so further multilingual support is needed. Disabled parking spaces weren't identified in our real council smart parking database, and we found that in another project as well. So for users of mobility challenges, we need to identify suitable parks for them, both in proximity to where they're trying to go. So the app needs to ask the person what they're trying to do and where they'd like to go, and then the parks themselves have to be identified and reserved. Payment history review is needed. We found that we couldn't satisfy that particular request from a persona. The user guide is also needed to, and possibly in multiple forms, to help people with actually learning how to use the app effectively. The search function was better than the smart parking apps we tested from the App Store, but then it needs further improvement for different groups of users. And there needs to be a way of providing support for users when they encounter problems with the app. So we have a related paper in COMPSAC this year talking about human-centric defect reporting. And this is the kind of thing we need to add to this app to allow users to report either frustrations they're having with it or functionality requests that suits their diverse human characteristics. We'll learn a number of lessons, then recorded in more detail in the paper, just a few key ones. We need a diverse range of users and requirements going on, as diverse as possible, particularly when we're doing smart city-based applications. We need to be able to perform these same tasks in multiple ways to suit different user characteristics. That could be related to many different preferences and characteristics of the users. Accessibility needs to be designed when you start. It's very hard to retrofit. Some tasks need very different approaches for different user groups. And we used app reviews to help us identify specific problems with existing apps. And they proved to be very valuable to both help us construct personas, frustrations in the personas, construct some of our user stories, and also to validate whether our proposed smart piping application had addressed the common complaints of users that exist in smart piping applications that are available for current use. To conclude, smart city and smart living applications need to support a very diverse range of users. These users and these user characteristics are very different from each other. They're also very different from most of the software engineers that design and develop software, smart city apps. We need a better understanding of the range of goals, frustrations, and the tasks that users are trying to perform with these smart city applications. And we do need to support some tasks achieving exactly the same goal or outcome in some very different ways. Thank you very much for listening, and I hope you'll enjoy reading up.